So for this tutorial, we are going to build a neural network model and then use that to predict malaria outcomes. So that is what we are going to do. The data that I'm going to use is from this paper. I obtained it from this paper. And by the way, I am a co-author of this paper. In this paper, we use machine learning approaches to classify clinical malaria outcomes based on hematological parameters. For those who don't know, hematological parameters are measurements of the blood. They include hemoglobin levels, platelets, and then white blood cell counts. So that's about it. We are now going to split our data. For this exercise, we are going to split our data into three: training, validation, and then test sets. The training set is used for training the model. Validation set is used to evaluate the model during training. It's also used to tune the model. So when you are tuning your models, you always need to evaluate. Okay, and that is where the validation set comes in. So it's used for evaluating the model during training. The test set is used to test the model after training and tuning has been completed. So the test set here, we don't use it. We only use it after the model has been trained and tuned. So it's an independent data set. This test set, the model is not supposed to see it. Okay, we only use it at the last stage after we have done all the tuning, training, everything. So that's what it is. So this code here will help us get the three subsets. So I'll run this to do that. Okay, so I have my data here. I'll now proceed to build the neural network model. So here I have two hidden layers and I also have an output layer here. So that's what I have. So I'm going to run this. You should know that the best architecture is obtained after doing experiments. You always need to experiment and then you get the best architecture or the best performing architecture. So for this exercise, I had to do some experiments and this is the architecture that gave me a good performance. So that is why I'm using this architecture. So take note of that. I also explain something here with the compilation. After building the model, you need to compile. So here the loss function I'm using is categorical cross entropy. This is because we are using a one-hot encoding scheme. So take note of that. And then the metrics I'm using categorical accuracy. So take note of that. Optimizer I'm using Adam. And notice I have also set a learning rate. So that's what I have. The learning rate can also be tweaked. So depending on what you want, you can use the default learning rate or you can also specify your own learning rate. So all these things, these are experiments you have to do and then you get the best architecture. So take note of that. So let's run this. Okay, now we are going to fit our model to the training data. So we use this to do that and we also specify the validation data here. I have my batch size, I have my epochs, which is 200. And I also have verbose equals 1. Yeah, so the verbose equals 1 lets Python display some information for us. Okay, so information, we have the verbose equals 1 will let us know the accuracy and the loss as the model is being trained. So I set it so that we can see what is happening with the model. So we are now going to fit the model to the trained data using this code. So I'll run it now. Okay, so training has started. So we can wait and then we'll see how it goes. Okay, the model has been trained. So let's proceed. After the model has been trained, it's important to visualize the model. Okay, we need to visualize and see how the model performed. during the course of the training. And so we do that using this code here. So this code here will give us a summary and let us know how the model was performing, okay, for each epoch. So that is what we have here. So I'll run this to get the visualization. And now also get the one for the loss. This one is for the accuracy. Then this one is for the loss. So I'll display both. Okay. So let me just explain some few things here. So if you look at the accuracy, we see that the model improved. Okay, it was improving over time. So here we have the first epoch, and then as it moved along, the model was improving. So if you look at this model, this is how we expect a good model to behave. The behavior, I'm talking about the accuracy for the training and validation. Here we can see that the accuracy for the training and then that for the validation, the values are not far off. This is what we expect a good model to do. Okay, we expect that training and validation scores will not be that wide. The difference will not be that wide. If it becomes wide, then there's a problem. Okay, if it becomes wide, you need to investigate, and that is why this visualization is important, because it lets you know if your model is behaving as expected. So take note of that. We also have the loss, and we see that the values are not far off. So the model is behaving well. The behavior of this model is as expected. So we will proceed. And you can also check here validation and accuracy. We see the values here. Okay, around 0.83. Here the range is between 0 and 1, so around 0.83. Okay, so that's what we have. So with this plot, we can see that the model is performing well, because we can see it has a high score, 0.83, which is above 0.8, which is good. Okay, so now we are done with the training, and so we are now going to predict on the test data.